going to be John Amdur. He's the VP of AECOM, Unmanned Aerial Systems. John is the Vice President and a Manager of the Commercial Aerial System, UAS, and Global Program. You have about 100,000 employees? Wow. This whole drone thing is really exploding in every single angle. So it's a pleasure to have you here. So we're looking forward for your presentation.
Thanks. Thank you. I'm really excited to be here. I'm really I got into this position because I'm kind of a techno nerd, and I embrace that. Is there a clicker? Yeah, there we go. There's this UAVs, UAS, remote sensing is all in its infancy right now. I see it kind of like where computers were 20 years ago or so, where people were fighting over, well, who's going to get a 286 on their desk and who's going to get stuck with the older systems. And, but the amount of data that's being generated now is mind-boggling. And it's only going to get worse, I guess, and one way to say it. So one of the themes I want to talk about is how much data we're generating, how much data we really need to generate, and how we process and use and store that much information. There are three elements to unmanned aerial systems. The UAV, which basically, with in all due respect to our UAV producers, just is a truck, basically, that's there to get the sensors where you want them to go. There's the sensors, which is where the rubber starts to meet the road as far as data. And there's the software that takes that information and processes it. What I want to do is I want to talk about some of those, each one of those elements, and really, I'm kind of the ultimate end user. As you said, I have 100,000 employees in my company in 150 countries. We work for about every industry and every environmental group you can imagine. So, I have a perspective on where the technology needs to go, and that's one of the things I want to share with you, is just thinking through kind of next steps. Oops, wrong way. Okay. So UAVs are getting the sensors where you want them to go. The UAV development has just skyrocketed and made tremendous progress. But really, we're not going to get to where we need to be until we satisfy, at least in the United States, FAA on sense and avoid and the ability to safely use UAVs or UAS. I'm going to call it UAS. I know there's some discussion here about that. Well, you call them drones, call them UAVs, call them UAS. I call it UAS because it is an unmanned aerial system. It includes the flying system, it includes the sensor. So it's really, in my opinion, it's a UAS. So we need to satisfy FAA on how we can fly these systems safely. Now, I've worked with some groups that are doing development in that field. They're working on, I don't know, some of you may know what a phased array radar is. It's the same type of radars that they use on Aegis cruisers and AWACS planes. But they've miniaturized it to the point now where it fits into something the size of a 16-ounce can. It's in the development stage. The problem I have is that even when it's that small, it's taking up a capability in small systems that I don't have, that I can't afford. It's taking power, it's taking weight. So is it really practicable to have a system, a sense and avoid system in a small UAV? Now, perhaps we'll just suggest that maybe there's a way of having ground-based systems, like a ground-based radar, that can take up that capability. There's, for localized work and working in a mine and working on a construction site, there's plenty of different types of systems that I can use that are close by, and I can keep an eye on them. And then for longer range, there's systems like the ScanEagles and larger systems that are very capable that eventually will be able to have sense and avoid systems on board without using up all the capability that you want for sensors. There's a gap in between there somewhere where I want to be able to fly systems between 5 and 10 miles down a railroad, down a roadway, a highway, any kind of linear, down a pipeline, any kind of linear facility that I don't want to go to a huge system for, then there's got to be some way to get there where we'll still be able to fly. And of course, increase in duration and the reducing the amount of energy that the systems will require, so you can keep them up longer. You know, most of the rotary wing systems, anywhere from 30 to 45 minutes, something along those lines, which is good, but it's not quite long enough for some projects. And then again, you know, some of the more fixed wing systems have longer duration, depending on if they're gas or electric or so on. And then one of the things I do want to discuss is specific systems to support specific specific needs. So for example, I have clients that want to do bridge inspections. Well, when you start doing bridge inspections, it gets really difficult. You have a lot of infrastructure that's in the way. You want to get up and underneath. You want to be able to look up at structures and down at structures. So being able to develop a UAV that's capable of filling that need is really key. Another one is resource exploration. I'll talk a little bit about the sensors that have to go in that system, but we've talked to mining companies, for example, that are interested in doing exploration. And they say, well, can you fly and do exploration for us? I say, yeah, I think we could do that. And they go, well, can you do it in the Congo? And I go, yeah. And they go, can you do it in Afghanistan? And I'm like, yeah. So, you know, the reason you want to use UAVs is because it's dirty, dull, or dangerous. In this case, it's all three of those things. So, you know, how do you do that in a safe manner? So you want a system, and unfortunately, some of the systems that are required for doing exploration, you have to be very close to the ground to be able to do that. And I'll talk about this one system, LIBS, in a minute. I'm going to talk about sensors, but you have to be pretty close. So how do you get close and be able to fly these long distances? Well, maybe there's systems. Actually, I just realized none of my pictures are there. Did they come in? Oh, there they go. I don't know how that's happened. So you see on the right there, there's a lighter than air vehicle. Well, that's something that can hover, that can get close to the ground, and can go pretty long distances. But there's really not a whole lot of folks who are looking into how to use lighter than air vehicles right now for long distance work, especially. There is some, mostly government stuff, but it's mostly stationary. It's not really moving. Let's talk about the sensors for a minute. Some of the development needs are greater range and standoff distances. I want to be able to fly over pipelines and fly over transmission lines at a greater distance and still be able to get the level of data I need. Lower energy requirements so that they are capable of lasting longer and generating more data, which is an issue as well. And more specialized equipment for chemical leak detectors, like optical vapor monitors that can be put into aircraft. This is all in the development stage right now, but to be able to fly over long pipelines and be able to detect leaks at a distance is very valuable. Laser-induced breakdown spectroscopy, which is what I was talking about for the mineral exploration. The equipment actually has to be very close to the ground to do that. So we're looking at things like, can these things be put into quadcopters, octocopters, and so on, and almost landed on a surface in order to determine its geologic makeup? Is there another way of doing that, again, depending on the systems? Green laser technology, so you actually see into the water column. It's a new technology. It's very large right now, very expensive, but it holds a lot of promise. For example, NOAA was able to count tuna in clear water down to 250 feet using green laser technology. And then flash LiDAR. I don't even know if there's a name for this, but when you're doing bridge inspections, for example, I don't need to do a LiDAR scan of the entire bridge. Basically, I need, especially concrete structures, I need to look at the entire bridge. So doing photogrammetry is probably fine. But when I find a crack, I want to measure that crack. I want to be able to determine if it's growing. So the best way to do that is to use something like LiDAR, where you can get the image of that crack and follow it over time. So, but I don't need a LiDAR image the entire bridge. I need a photograph of that one section, and it would save a lot of space and data in order to do that. Another area we've been looking into is in-place sensors and how you can combine in-place sensors with the data gathering capability of UAVs. So, for example, when you're looking at dams or levees, You want to monitor motion of those levees for seismic reasons, obviously. Well, you can use aerial systems to do that. You can also use these really cheap, I mean, $25 in-place monitors that can detect the slightest motion. So you can $25 a piece, you could put a lot of those sensors out and look for motion and collect the data using a UAV, also collect LiDAR data or photogrammetry in order to determine if there's any motion going on. And then smarter sensors. I have a concern over the amount of data that we're gathering. If you were in the discussions earlier today, Tim was talking about how he had taken the Rembrandt, the bigger Rembrandt, and had, I think it was 1 billion data points that he collected from that photo. Well, what happens if when I want to go out and I want to do the same thing for the gates of the Arctic National Wildlife Refuge? 700 square miles. I mean, it's a resource that we have to guard. It's information we need. We want to know what's happening with the land. We want to know what's happening with the vegetation and the animals. I mean, how much data is that going to be to store? So when I talk about smart sensors, I'm talking about sensors that are capable of knowing what your data needs are going to be. So it's collecting the right amount of data. There's a lot of issues right now, and I talk to clients constantly over what they really need. Everybody wants to jump to the Cadillac and they want to use LiDAR, but I say, yeah, you can do that, and you're certainly going to get the data you need, but is it a lot more than you need? Even when you get the LiDAR data, for when you really want that accuracy, about 20 to 30% of that information you're going to clean out. So do you really need that? That's a lot of data processing you need to do. So there might be better ways of doing it using photogrammetry and just really understanding what your needs are and designing your projects just specifically for that. Another thing is improved positioning, which will add to the accuracy when you're doing 3D modeling, contour modeling, surveying work. It's I'm finding the clients by and large can live with somewhere between 3 to 5 centimeters of accuracy, but a lot of folks want that 1 millimeter of accuracy, 1 centimeter of accuracy, or less, so they can do actual design and engineering work on that. There's planning levels and there's design levels, and a lot of clients want the design level. And to get there, it takes a lot to get to that level. You have to add ground truthing locations. You need other systems in order to make sure you have the level of accuracy you need. And then post-processing. So again, it's a lot about the data. It's about better, quicker ways of cleaning up the data so you're not storing as much, so the processing time is reduced. A lot of folks want to see that information right away. It depends how big the project is and how you're doing it, photogrammetry versus LiDAR versus whatever. So it's a lot of information to crunch. And then the other thing I really wanted to, for you developers out there, I really want to talk about optical character recognition and the value that would bring. I don't think there's enough work going on as far as optical character recognition right now. If you look, the photos I have here, you can see the desert tortoise and salmon in the stream. I would, when we go out and do a survey for desert tortoise, we might have biologists, wandering, tens of miles through the desert, if not more than that, looking for desert tortoise, where it could be done much better through an aerial system. But then you have thousands of photographs to go through, and that can get pretty tedious. So wouldn't it be nice for my biologist, for example, to be able to put in parameters in which the photos would be flagged for things that are close to what a desert tortoise looks like, and then they can go back and verify what that is instead of going through thousands and thousands and thousands of photos looking for desert tortoise. And of course, it goes to much beyond desert tortoise. It goes to any biological species you can think of. And then also on the engineering side, I mean, when you're going through and you're doing these doing the reality capture, whether you're counting doorknobs, window frames, fire hydrants, or whatever, it would be really nice to have systems that are able to, like that, identify those types of systems, and get that into your drawings. So just some final thoughts. I think we need to look beyond the systems. It's all about the data. So yeah, we get fixated on the technology and getting more data, and I think the next point is that more data doesn't necessarily mean better data. It doesn't necessarily mean better decisions. I think people have to think about how much data you really need to get the answer you need, so you're not over-collecting and over-stuffing your systems. My company, along with other things, builds data centers, and I know what it takes and how much it takes to run a data center. And you're talking about scanning huge areas and collecting all this data. You need a place to keep it. Even if there's enough space for it, it comes at a cost. So just collect what you need and think about what you need beforehand. The oceans are the next frontier. We spend a lot of time talking about terrestrial stuff, and I think there's a session, maybe tomorrow, about ocean work. I believe that there's a huge need to look at remote vehicles for ocean exploration. If you look at the systems that our developers are coming up with, aerial systems, they're small, they're getting smaller, they're getting more affordable. If you look at ocean systems, we're talking about millions of dollars for an ocean system. I think we need something something in between that would a lot cheaper than that to provide value to ocean and in-water exploration. And the last thing is, I call it drone, you call it UAV. In order to make progress and get people comfortable, I've even heard people say here today, it's like, oh yeah, we have to worry about privacy and all these kinds of things. In order to make progress with UAVs, we have to understand the human side of it. I lay in my backyard and I watch Google fly over and take pictures. But if a drone did it, people would be having kittens. So, but I personally don't understand the difference. I think that what we need to do is we need a good publicity agent for UAVs, because they can do so much good. There's so many positive things. Any new technology has the ability, somebody could use it the wrong way, whether they're crashing into the White House or flying too close to an airport or whatever they're doing. Somebody can do the wrong thing with these pieces of equipment. But that's such a small percentage. So much good could come out of it, and we just have to get the message out about the wetlands we can restore, about the infrastructure we can protect, about the lives we can save using UAVs and remote sensing technology. And that's it. So thanks.